What's up, developers? In this video, I'm going to walk you through the system design of a waitlist web application hosted on Cloudflare. First, we'll take a look at this mockup that I've created. Second, we'll go through these designs that I've created. Third, we'll talk about what Cloudflare gives us. And fourth, I'm going to go back through my notes down here to make sure I didn't forget to tell you anything. So with that out of the way, let's go ahead and dive in. So here's the design of the waitlist that I currently have. This is the waitlist we'll build in this course, and I'm planning to improve the design of this. As you can see, it's a little plain and boring right now, but this is the dummy version that I created as I was building out the course. So when we're looking at this, it really helps to paint a picture of what's going on. And there's really two key parts of this that I want to draw your attention to. So first, this is all static, so we don't really need to pay too much attention to that for the system design. And this also down here is all static. And when I say static, that means it's going to be the same for every every user who comes to our website. They're going to see the same thing here and here. The user will see the same thing, but this actually interacts with our API and saves the email to the database. So this needs to be a live piece of our website. And same with this down here. The number of people who sign up for our waitlist will change. So this number needs to be fetched from our API, which will then grab the updated number from the database. So that kind of gives you just a quick visual of what this looks like as we start talking about the actual system design over here. Now, the best way to walk through a system design diagram is to start with the user. So what happens when our user goes to the internet and types in our domain name into the browser? So for our system, this will be hosted on Cloudflare. So Cloudflare has a CDN. So this is the first thing that's going to happen, is that the browser is going to reach out to Cloudflare's CDN network. So what is a CDN and why? Right? What and why, the two most important things. So a CDN is a server that caches static assets. So static assets would be, I list that down here, JavaScript, HTML, CSS, images, and Cloudflare has a network of these, like over 300 different data centers across the world. And so it can serve the initial load of our website very fast. So yeah, the what is it's a caching server. The why is it gives us speed. So then the server is going to send those assets back to the user, and our website is going to load for them. And so these static parts of the website are going to load very quickly. And then these dynamic parts, for example, this will load quickly, but here we're going to need some kind of loading state because it's going to need to then later fetch this number from our API, which will then go to the database to get the updated number of developers who've signed up for the waitlist. So after they receive these static assets and the website has loaded for them, as I was mentioning, then the website is going to send a request to our Cloudflare worker. So our worker is what's going to be hosting our API. And we're going to have a few different endpoints for our API that I've listed out right here. And sorry, I should zoom in more so you can see it easier. So first we'll have the get API subscriber count. So that's what I was just showing in the image. We want to get the number of subscribers so that we can show that on our waitlist. So this the browser will make a request to our Cloudflare worker to this endpoint, which will then reach out to the Cloudflare database. And Cloudflare has a D1 database service, which is SQLite based. And that's where we'll be storing our data for this course. And then the database is going to respond with the count of subscribers, and then the Cloudflare worker is going to send that number back to the browser, and then the user is going to see this final state here. So then what happens when the user puts their email address in and clicks the join button? So we then need another API endpoint. So the user will have the API signup endpoint. They put their email in, submit it. It goes to our Cloudflare worker. Our worker is then going to do some validation on the email, make sure it's in the correct format, and make sure it's not a duplicate, and make sure there's no plus addressing. But then it will store that email address in the database. So our worker is the interface basically to our database of saving and getting data. And I think I wrote that right here. So, like, what are workers and why? So, workers are going to be instances of our Hono REST API, and they can process the data requests. So, that's getting the number of subscribers and saving the email. And like, why do we even need this? Why wouldn't our browser just interact directly with the database? Well, workers give us the ability to clean the data and interact with our database in a safe way. So we don't want users to be able to hit our database directly, because there are malicious people out there who might try to blast our database with a bunch of fake email addresses, and who knows what else they might try to do. But we want to protect our database. So you can think of the worker kind of as the guardian protecting our database. Um, so that covers the sign up endpoint. And there's one other endpoint that you can see here. So let's talk about this. So when the user submits their email, we want to confirm that it's called a double opt-in, confirm that that email address is really valid. So we will send an email to that email address, and then the user will click that confirm button inside of the email. And then when they do click that confirm button, we'll update our database to say that that email record is valid. So why would we do this? And that is because of malicious users, like I was just mentioning a moment ago. Some user could easily create a script where they're sending a bunch of signup requests to our worker with fake email addresses and loading up our database with fake emails. And if they do that, how would we know? And how would we then go through and delete those fake emails that got in there? Well, that's where the confirmation endpoint comes through. So for each email saved to the database, it'll have its own record, and then we'll have a column that will say whether that email is validated or not. So after 48 hours or something, we can go through and delete all of the emails that weren't validated. And so the way that this will work is when the user clicks on the email, it will trigger this API confirm endpoint, and there will be a special token linked to their email address. It will come to the worker. The worker will validate that token and check if that token exists in our database. And if it does, update that email to be valid. If not, then we're going to tell them, hey, this token's expired or invalid, something like that. And then, I forgot to mention down here. So to send the email, we're going to be using Resend, which is an email provider, and they will actually send that confirmation email to the user. Now let's take a look at this global version that I put together. So this is pretty simple, but it's just another look at the system design. So we're going to have users potentially all over the world. And what Cloudflare gives us is a global network, which is pretty amazing. So these server icons represent the CDN servers that I mentioned earlier, and then these are our Cloudflare workers. So without us needing to do anything, when users reach out to our website, Cloudflare will automatically get them the static assets from the CDN network, which is global. So it'll reach out to the CDN server that is closest to the user. So this user is not going to reach out to this CDN server. They're going to reach out to this one because it's closest to them geographically. And then same thing with the workers. So once they have the static website and requests are sent to our API, it will it'll reach out to the Cloudflare worker that is closest to them. So that way our user gets the fastest experience possible. And then our Cloudflare workers will read and write to our database. Now, you can see here in the diagram that there's only one database. I don't have databases all over. And the reason for that is because by default, when you create a Cloudflare D1 database, it will only create one instance of your database, which is located closest to you. So I'm in North America here, so my Cloudflare database is going to be created here closest to me. And then all of the workers around the world are going to read from this. Now, you might be thinking, okay, well, isn't that going to make our system slow if all of the different workers have to read from one database here? Like, what about this person? This could be very slow for them. Well, in some situations, yes, but for a waitlist, you know, a waitlist is not a data intensive website. People are going to come to the waitlist once and then they're going to sign up and then they're going to leave and they're not going to come back. So it's not like Facebook where people pop it open 10 times a day where it's constantly reading and writing data. This is not data intensive. So one database is good enough for us for the for this system design. If this was a more data intensive application, then yes, we would want a different solution. And that solution might be that we could still use the D1 database, but we would want replications of our database all over. So that way, like this user would get the database closest to them. And that would be an option. But it's important not to over engineer, right? That happens all the time in the real world where people are over optimizing, over engineering, and making their system way more complicated. So for this, the data demands do not warrant replicating the database everywhere. Okay, let's jump down here to my Cloudflare notes and make sure I didn't forget to tell you anything about what Cloudflare is giving us. So I mentioned users will automatically connect to the worker closest to them. So that's a great performance feature from Cloudflare. And when you create a D1 database, by default, it's created at the data center closest to you. And then you can create read replications of your database to improve the performance. So if it was more data intensive, then we would want to do that. But for our application, just one database is going to be fine. And then Cloudflare CDN will serve our static front end globally. Yep, mentioned that. Cloudflare has 300 data centers worldwide. So, yep, mentioned that. Basically, users worldwide will get a really good, fast experience by hosting on Cloudflare. Cloudflare also has some bot prevention and traffic blocking that we can enable to protect our website, and we'll definitely do that. Cloudflare has metrics to show us unique visitors, and this is good for measuring our conversion rate too. So with a waitlist, we want to see how many people landed on our website but didn't sign up. And being able to track that percentage of people who actually converted and signed up can help us see like if our website, if our waitlist might need some improvements. Like maybe it's not communicating the value of the product, or maybe people are finding this website and they just don't care about the product. So both of those are good to know when thinking about building out a product is, you know, if people are interested or not. Then Cloudflare also has logging, so we can see like what's happening inside of our workers. So we'll enable that, and we can enable a custom domain. Cool. So Cloudflare gives us a lot of options out of the box. And, well, I shouldn't say out of the box because we have to enable some of these, but it really is a very good balance of control and like developer experience. If you compare Cloudflare to AWS, AWS is so complex. It has so much going on, and there are DevOps engineers where their entire job is just to manage the AWS account, and they're paid, you know, 150K a year. Whereas with Cloudflare, a full stack engineer can manage the Cloudflare account and all of that hosting without needing a separate DevOps engineer. So it's a lot simpler, but it also gives us a lot of different options without being overwhelming. Now let's cover some of the last details that are over here in my notes. So taking a look at the front end first, this is going to be built with Astro and React. And Astro is built for static site generation. That's what SSG is. And so what that means is it'll take all of our code and build it into static HTML with just some dynamic parts, which are two dynamic parts, again, are the email and the number of developers. And so everything else is going to be SEO optimized because it'll just be the plain HTML. And that way, web crawlers can find our website and read it easily. And then the sign up feature, we're going to, on the front end, we're going to want to validate the email in the browser. That's a good experience for our users so they know if they accidentally type in a bad email address, missing the @ symbol or the .com at the end, we'll say, hey, this is wrong. Gives them a fast feedback loop. And then we also want to disable the join button and show loading after the user clicks to prevent spamming, because if we don't do that, they'll have no idea that there's a process happening on the back end and our worker is saving their email to the database. So we want to disable and put a loading state. Otherwise, they're going to just keep clicking the join button and think, hey, what's going on? Why is my email not joining? And then afterwards, we want to give them feedback too and show them either success or error if we manage to save their email to the database, show them that success message or error, and then give them some kind of option on error, like, hey, you can try again maybe in a couple minutes if there's the system's down, or say, hey, the email address was bad, and give them some kind of feedback on how to fix that error. And then we want a confirmation page. So this will be after the user gets the email. So they send the email, they submit their email, they receive an email to confirm. They then click on the thank you, or the they click on the confirm email. Then the user will be redirected to our thank you confirmation page when they click that confirm email. And then for subscriber count, we'll also need a loading state and an error state in case that number of subscribers fails to fetch for some reason. And in regards to SEO, so the static site generation I mentioned earlier is going to help for SEO, but there's a couple other things we can do. So we can add tags for sharing on social media, and then we can add a sitemap XML and a robots TXT, which help web crawlers like Google to understand our website better, and that way we can rank better with Google. And then we want to, of course, optimize for both mobile and desktop friendly design. And Tailwind CSS helps with this a lot. Tailwind has different size components, so we can show the display a little bit differently on mobile. For example, these 3 cards on mobile will be stacked vertically so that a user can see them easily without trying to have 3 cards all jammed side by side on mobile. That would be really ugly. And then we'll need a 404 page in case someone puts in a bad URL somehow on our website and ends up on a page that doesn't exist. We'll want a 404 page and a button that says return home, bring them back to the main landing page. And some other kind of housekeeping items, we would want a copyright, terms of service, privacy policy, and a contact method, some way for people to reach out to us if they have questions. And for the backend, this will be a Hono REST API with Zod for validation and Drizzle ORM for interacting with and managing the database. So some considerations with the Hono REST API. We'll want a CSRF middleware, which Hono has built in, and that stands for Cross Scripting Resource Forgery. I believe that's what it was. It's a security thing to help protect our users from cross scripting. It's an attack where a malicious user can make requests as an authenticated user. So basically impersonating them. And this is a very easy middleware to add, so we're going to do it. And then rate limiting, that's another important part of protecting our system. So a malicious actor could create a script to send a bunch of requests to our database with fake emails. So I talked about that before. And there's another way we can help protect ourselves is with rate limiting. So we can say, okay, this IP address, they can only send us 3 requests per IP address. If they're sending more than that, then we're going to block them. That way, a malicious actor can't fill our database with hundreds or thousands of fake email addresses. Maybe they'll just get a couple fake ones in. And then we can remove those fake ones because they won't be validated. And then talking about, okay, so get API subscriber count. We've talked about that. The post request to sign up. So we'll use Zod to validate the email and make sure it's in the correct format, a valid email format, and save it to the database. And then plus addressing. I mentioned this a little bit earlier, but not in depth. So for example, Nichols and Codes plus 1234 at gmail.com. So this is plus addressing. So people often do this when they want to kind of reuse their email in multiple places. So I don't want somebody to sign up, again, a malicious actor signing up 1,000 times with this plus addressing, which would go back to their email, and then fill our database with basically duplicate emails. So we want to clean that up, remove that, and if they're doing that, then send them some kind of feedback saying, hey, plus addressing is not allowed, and we can display that in the UI. And then for capturing errors and alerts. So Sentry is a product. Here I can pull up their website, Sentry.io. So this is a tool that I use at work. We use it to monitor and catch errors. So when an error is thrown inside of our app, Sentry will capture it, and then you can set up alerts. So I could receive an email and say, hey, there was an error when somebody tried to sign up. That way I can start debugging early. If there's some error in the API and people aren't able to sign up, I'll get notified about it. So that's really the value of Sentry. And then optional query param for traffic source. So when I say query param, here's an example URL, https example.com with the question mark. So this is the query param. And then I can put traffic equals LinkedIn, for example. And that way, when the request comes in, I can grab this query param and store this in the database and say, and try and track where a lot of my traffic is coming from. Is my traffic coming from YouTube or LinkedIn, or how are people finding my waitlist? And that information can be valuable and help to figure out, where to focus your time and energy. And then another thing that our signup endpoint will need to do is generate the confirmation token and save it to the database. So the confirmation token will need to be unique for each record. And then when the user, I guess we'll talk about that here, the API confirm, it will match that token up with the record in the database and update the subscriber to say that you are now verified. Sorry, spilling over from here to here a little bit. And then once all of this is done, we'll send the confirmation email via Resend to the user after they sign up. So now getting down to here, I jumped ahead a little bit. We'll accept a query param token in the URL, which that was this up here. So be API confirm query param token. So we'll grab that token, look for that token in the database, and then validate the user or say, hey, this is an invalid token. And then afterwards redirect the user to a thank you page. So that's how that will all work. And then Drizzle will be for managing our database connections and queries. And now for the last thing is the database, the design of that. So as I mentioned, we'll use Cloudflare D1, which is SQLite based, and our subscribers table. So we'll only need one table in this database. So not too complicated, which is nice. And we'll store the email, which will be text, and this needs to be unique. So if it's not unique, our database will throw an error, which is good. We don't want duplicates in our database. We'll store the created at timestamp and updated at in case we ever need to update the traffic source, which will be text, and that was like LinkedIn or YouTube or wherever we put our URL, try and track where it came from. And then device, we want to record whether it was mobile or desktop. That information can be valuable because if everybody's coming mobile, then you want to put a little bit more effort into the mobile design. Or if everybody's coming desktop, then put a little bit more effort into the desktop design. And then the email verified. So this will be a timestamp, and this is what happens when they click that button in the email that they receive to verify, and then unsubscribed. In case someone wants to, unsubscribe, we'll keep that timestamp. And then last would be the confirmation token. So that's how we will match up when that person clicks the email to match it up with the email address here and verify the correct email. So that is all for this system design. If there's some parts of this that were confusing, don't let that discourage you. As we jump into coding, a lot of this will start to make more sense. Thanks for watching. Happy coding and Godspeed.